Hi everyone. Today we are going to learn how to graph linear inequalities. So before we actually start graphing, we're first going to answer a very important question. How can we tell if a coordinate, an xy coordinate, is a solution of a linear inequality? So to see if a coordinate is a solution, we're going to substitute the x and y values of our coordinate into the inequality. And then we're going to look at the statement or the inequality that it produces and decide if it's true or false. If you end up with a true statement, then it is a solution. And if you end up with a false statement, it is not a solution. So let's see if we can give this a try. So it says, tell whether the ordered pair is a solution of the given inequality. So for part A, our inequality is 2x plus y is less than -3. And they want to know if -1, 9 works for this inequality. So I'm going to label this x and y so I know what to substitute. So remember, whenever we're substituting, we use parentheses to do it. So I took out x and y. I'm going to replace x with -1 and y with 9. Now we just need to simplify. So 2 times -1 is -2. -2 plus 9 is 7. So we look at this statement. This statement reads, 7 is less than -3. So this is definitely not a true statement. 7 is not smaller than -3. So since we have a statement that is not true, we would say not a solution. There you go. So for part B, our inequality is x minus 3y is greater than or equal to 8, and they would like to know if the xy coordinate to -2 is a solution. So let's set up our substitution. So I'm going to substitute x with 2 and y with -2. And let's simplify. Here we have 2 plus 6 is greater than or equal to 8. Remember, when we're multiplying with two negatives, our answer is a positive, and then 2 plus 6 is 8. So this statement reads 8 is greater than or equal to 8. So this is a true statement, which means the coordinate 2, -2 is a solution. Okay, go ahead and pause the video and give these two problems a try. Determine whether the given ordered pairs are a solution of the given inequalities. Okay, let's check. So for the first one, you can see my substitution yields a statement that says 0 is greater than 0. This is not a true statement, so it is not a solution. For the second problem, here's my substitution. We end up with a statement that says -18 is less than or equal to -1. Now this is a true statement. -18 is smaller than -1, so we have a solution. So now we're going to try actually doing some graphing, and you'll see why we'll need to check to see if coordinates are a solution in just a moment. So when you're graphing a linear inequality, we want to graph it very similar to a linear equation. We put our inequality into slope-intercept form. We want it to look like y equals mx plus b. And of course, we start by plotting the y-intercept, which is b. That's our starting point. And then we follow the slope, which is m. However, instead of just connecting the dots right away, there's two extra steps to think about. So the first one is with inequalities, sometimes you use a solid line and sometimes you actually use a dotted line to graph. So if you are simply working with greater than or less than, meaning there's no or equal to, so there's no line, we're actually going to use a dotted line. So we use a dotted line to show that those numbers are not actually part of our answer. If it doesn't say or equal to, they're not part of our answer, so we use a dotted line. But if you see a symbol like this, greater than or equal to, less than or equal to, we can use a solid line just like we're graphing an equation. Now the second thing you have to do is we're actually going to shade our graph, because as we know, with an inequality, there's not just one answer, there's actually an infinite number of answers, all of the things that are greater than or all of the things that are less than. So if we are working with any type of greater than symbol, we're going to shade above our graph, because greater than means bigger, and the bigger numbers are always going up above our line. And if you see anything with less than, so less than or equal to, we're going to shade below our line, because less than means smaller, and smaller numbers are always down below on a number line. All right, let's give a couple of these a try. So this first one is actually a special type of line. This is going to be a horizontal line because I only see y. So the way I think of it, we can rewrite this as y is less than or equal to 0x plus 2. This is in slope-intercept form. So I can see that my y-intercept is at 2, and I can see that my slope is actually 0. And lines that have a slope of 0 are just horizontal lines. The only thing I need to consider right now is whether I should do a dotted or a solid line. And since I see this or equal to symbol, I'm going to actually do a solid horizontal line through 2. Now, since it's an inequality, I need to decide, should I shade above or below my line? Since this inequality reads y is less than, I want all the numbers that are smaller, and therefore all the numbers that are below. So I'm going to shade everything below the line. And this is a way of showing graphically that all of these coordinates work for this inequality. Now, we are going to double check that we shaded in the correct location by picking a random coordinate and seeing if it's actually a solution. So this is like what we did in the first example. You can pick any coordinate you want that's in your shaded area. So I'm just going to pick 0, 0 because it seems like an easy coordinate to pick. And I'm going to substitute it into this inequality. So I'm going to replace y with 0 and see if we get a true statement. So 0 is less than or equal to 2. Now, since this is a true statement, 0 is smaller than 2, I know that we shaded in the right region. Now let's go and try this graph. So here I see x is greater than 1. So I'm going to start by going on my x-axis and plotting 1. Now this is a special type of line as well. If you remember, I like to think of this as an extreme line. When you only see an x, I think of an extreme line, and extreme lines to me are vertical. So I'm going to do a vertical line through x equals 1. However, if I look at my inequality, there's no or equal to sign, which means I'm actually going to use a dotted line. So it looks like this. Now from here, I'm going to shade. This inequality reads x is greater than, so I want all of the bigger numbers. And I know on a number line, moving to the right is where all of the larger numbers are. So I'm going to shade all of my numbers, this region, to the right. And this is my solution set. All of these numbers are part of my solution. Now we can double check again. So we're going to pick any coordinate that's in our shaded area and see if it works. So let's say I decide to pick this coordinate. It can be any coordinate you want. So this coordinate is 3, 2, and I'm going to substitute into our inequality. So our inequality is just x is greater than 1, so I would say 3 is greater than 1. Since this is a true statement, 3 is larger than 1, we know that we shaded in the right area. Okay, go ahead and pause the video and see if you can graph these two inequalities. Okay, so for the first one, here we have a horizontal line through y equals -1. Since there's no or equal to, we use a dotted line, and since it says greater than, we shade above, and here's my double check. For number 7, here we have x is -4, so we have a vertical line through x. It's solid because we have this or equal to, and since it says x is less than, we're going to shade all of the coordinates to the left. Here's my double check to make sure that our answer is correct. Okay, now we're going to try one more together. This one is a linear equation that is not in slope-intercept form. So in order for us to graph it, first we're going to rewrite it in y equals mx plus b, which is slope-intercept form. So if we have -x plus 2y is greater than 2, I need to isolate y. So the first thing I'm going to do is move this -x. So I'm going to do that by adding x to both sides. Now remember, we can't combine 2 and x, so we're just going to leave it as x plus 2. 2 plus x is just x plus 2 or 2 plus x in whatever order you want. So I can see now that I'm a little bit closer to being in slope-intercept form, but my y is not completely isolated. So in order to get rid of that 2, we're going to divide both sides by 2, which of course means every single term. Now I'm going to put a 1 in front of here so this next step makes a little more sense. 2 divided by 2 is 1, so we have 1y is greater than. 1x over 2 can be written as 1 over 2x. And the reason why we want to write it like this is so it looks more like slope-intercept form. And then here, 2 divided by 2 is 1. And now this looks like something we can graph. So I look at this and I say, okay, my y-intercept, my b value is 1. So this is our starting point. So I find 1 on our y-axis and I put a point. Now, our slope is 1 over 2. Remember, this tells us rise over run, so it tells us to go up 1, right 2. And that tells us where our next coordinates are going to be. Or I can move backwards, down 1, left 2. Now, I need to look at my inequality and decide if it should be solid or dotted line. Since I do not see an or equal to, I'm going to use a dotted line, like this. And then I just need to decide if I should shade above or below my line. This one says y is greater than, so I want all of the values that are larger, so I'm actually going to shade everything that is above our line, just like this. So all of these coordinates are part of our solution set. Now, a way that we can double check, remember, is by picking a coordinate that's in our shaded area. So let's say I pick this coordinate. This coordinate is 0, 4. So let's plug it into our inequality, which is right here, or you can use the original one up here. I'm going to use this one to see if we get a true statement. So y I'm replacing with 4. 4 is greater than 1/2 times x, which is 0, plus 1. And anything times 0 is 0. So we just have 4 is greater than 1. This is a true statement. 4 is greater than 1, which means we shaded in the correct area. Okay, go ahead and pause the video and please give these last 2 a try. All right, go ahead and check your work. So here, remember, the first thing we're going to do is rewrite it so it's in slope-intercept form. For the first example, you can do that just by subtracting x on both sides, and you have y is less than or equal to negative x minus 4. Our b value is negative 4, so that's our starting point. Our slope is negative 1 over 1, telling us to go down 1, right 1. And we use a solid line because I see or equal to, and we shade below because it says y is less than, so all of the numbers that are smaller than it. For the second one, same thing, we're going to move x to the other side, leaving us with negative 2y is less than negative x. Now this next step is a little bit tricky. Hopefully we remember, with inequalities, whenever we multiply or divide both sides by a negative number, like we do here, our sign actually needs to flip. So when we divide both sides by negative 2, our sign turns into greater than. Now this, the negatives cancel out into a positive, and this is just 1x over 2, so we can write that as 1/2 x. So here I'm going to use my y-intercept, which is 0, and I'm going to follow my slope, which tells us to go up 1, right 2. I use a dotted line because there's no or equal to, and I shade above because it says y is greater than. Okay, that is all for today's lesson. Thank you so much for watching.